Welcome to today's webinar, Deep Dive of Flink and Spark on Amazon EMR. Our presenter today is Keith Stewart. Keith is a specialist solutions architect at Amazon Web Services in Boston, specializing in Amazon EMR Hadoop as a service. He helps customers understand and architect solutions using Amazon EMR, Apache Hadoop, Apache Spark, and other Amazon services to achieve business aims. He has decades of experience working with large-scale data in a variety of industries. Today with us, we also have Suman Koduri, Bruno Faria, Tony Nguyen. They'll be our webinar moderators today, be answering your questions throughout the presentation. So Keith, thanks for coming in. The floor is now yours.
All right, thanks. My name again is Keith Stewart. I focus on EMR, which, as was stated, is a Hadoop as a service, but it's actually more than that. It's a platform for massively parallel compute, runs a variety of applications, but we'll talk more about that. Today, I'm going to talk about an interesting topic, something fairly new. But stream processing is the key focus, but specifically we're going to drill down into Flink and Apache Flink and talk about its capabilities around stream processing, and also we'll contrast that with Apache Spark streaming, which is the popular solution these days for stream processing. So Flink is kind of the new kid on the block, but it's interesting enough for us to take a look at it. All right, here's the roadmap for what we'll cover. Three things. We'll talk about real-time stream processing. You know, why is that important these days, and what are the challenges architecturally to accomplish real-time stream processing? Second, we'll take a look at the Flink, Apache Flink in detail, and compare that to Spark streaming. But we'll try to answer these questions. You know, what are the aims of Flink? What is it, or how does it address real-time stream processing, the challenges that we identify? How does it differ from Spark streaming? We'll look at some real-world Flink adoptions, and then we'll take a look at maybe some recommendations about when you might use Flink and when you might use Spark streaming instead. And then, most importantly, we're going to drill deep into a Flink demo showing how we can deploy and run Flink on AWS and look at a rather visual and interesting demo. All right, so let's jump in. So the need for real-time streaming is something that's starting to ascend. We're seeing more and more of a need for that. And the kinds of examples where you need to look at data that's arriving in a continuous flow include things like cars that are moving and transmitting GPS signals, high-speed financial transactions, people interacting with their smartphones, and the interaction of those phones with cell phone towers, web traffic, including things like session tracking, understanding user behavior on websites, looking at machine logs, IoT devices, industrial sensors, and wearable devices. So it turns out that, you know, given where things are going in terms of technologies and the kinds of data that they're emitting, streaming data and stream processing turns out to be a better way to deal with the kind of data. It's a better fit for the way we consume this data. So what are the challenges in processing streams? It is a hard problem because of various challenges. So one of the key things is when you're processing streams, you need to not so much track when the data is being processed, but really dig in and leverage the event time, the time attached to the individual records that are streaming through the system. That's important to prevent out-of-ordering events, because for things like, example, session tracking, you absolutely need to know the proper order of events. You don't want things jumbled out of order. Stream processing is challenging to maintain consistency and fault tolerance, because with the dynamism that's associated with this data generation and processing, you need a system that can keep up with that and handle interruptions of connectivity, surges in data volume, etc. You also need the ability to consume the data from the stream processor. And so you need to be able to answer complex queries in the form of windows. You know, you need rich windowing definitions, different ways to pull out information, roll up and aggregate information, generate real-time alerts as you look for particular things of importance. And then finally, you don't want the system to get bogged down, so you want low latency and high throughput in a stream processor. So before we jump into Flink and streaming in particular, let's step back for 1 second and consider a generic or traditional big data pipeline. Here I'm showing abstract components, abstract phases for a big data pipeline. And typically you have some kind of collection. The data has to come in to the system in some way. Typically it's stored first, persisted so that it can be processed later. Then you have downstream of that the process and analysis of it, and as shown, the relationship typically between a store and the processing is an iterative one. So multiple passes are typically done, especially in batch processing. And then finally you have consumption, where the data, you may have some data coming directly from the processing or analysis, but you may also be dipping back into the store to take advantage of data that's persisted there. So on AWS, it's important to realize that we have a large variety of options for big data pipelines, and I'm not going to go into all of these, but I just simply want to increase awareness of all that we have to offer on AWS. And so you can see for collection, we have applications that can supply data. We have logging systems that can generate logs, documents, files, messaging, and then most importantly is streams. Okay, and so those come out of the collection system, they move into storage. We've got a variety of things like NoSQL, SQL, document indexing, files, etc. And then on the streams, you can run open source systems like Kafka, but also managed services like Amazon Kinesis and Kinesis Firehose, also looking at DynamoDB streams. And then on the processing and analysis, we have a large number of very capable, very high performance solutions, and including Amazon machine learning, a bunch of EMR based systems, and we'll talk more about that, and then there's consuming of streams. And then finally is a variety of tools, both available from AWS, but also from third parties, can be used to consume the data. One thing I want to draw attention to is a concept called temperature, data temperature, and you'll see that superimposed alongside the different technologies. So temperature is a very important consideration. What we mean by that is data that has a certain amount of velocity and volume. And so we make a distinction between cold data, which is data that you may move only periodically. You may store it and then not retrieve it for until much later. And then there's hot data, which is data that's moving very quickly through the system, and where you want to be able to extract answers from that data in real time. Okay, so we have a variety that spans the different temperatures. As we move into stream processing, where the various components of storage, processing and analysis and consumption can now have to deal with hot data that is moving at very high velocity, very high throughput, and so that means that there's certain technologies that are more appropriate, and I've shown those here. Okay. Now, Flink is one of the ones that was added to AWS, and we'll show how you can actually launch that in a moment. But Flink is as I said, the new kid on the block. This is a technology that was designed for streaming. It was developed among 3 German universities in 2010. It was put into the Apache project 2014, and so it hasn't been around as long perhaps as Spark and Storm, but it shows some interesting differences, and we'll drill down into those shortly. But Flink is what we're going to focus on now. By the way, Flink I believe is German for fast, so that's where they got the name, and they chose a quick squirrel, I guess, as the mascot. So Apache Flink, it's an open source platform for distributed stream and batch data processing. It's an interesting architecture in that it's stream first. It was designed to address streaming as a first-class consideration, but it also happens to do batch processing simply as a special case of a bounded stream processing. Stream processing that has a beginning and then an end is a batch. But streaming is the main focus for Flink. Here's the architecture, the components that comprise Flink. The really key component is the runtime distributed streaming data flow. So this is the fault-tolerant, low-latency, high-throughput backbone that is designed to handle streams, deal with event time, various windows, etc. And on top of that, Flink has some APIs that expose different ways of working with that. There's a batch processing API, a data set, and a data stream processing, and then additional libraries on top of that that allow you to work with Flink as the substrate, but attach things like machine learning, graph processing, and even relational table information querying. It can deploy in a variety of ways. We'll see in our demo, we deploy it using Yarn on EMR, but you can deploy it in a variety of other ways. So Flink is rather interesting in its behavior and its capabilities. So as you can see, it can handle multiple inputs. You can deploy your stream processing code, your specific logic, stream logic, into the Flink system. Flink maintains state for each of the inputs, tracks the timing of the events that are passing through, does checkpointing so it can recover from failures in a fault-tolerant way, and it knows when it's processed data and when it hasn't, and allows you to do interesting things. So down here we have a blow up of the kind of application that might be running in Flink. You have sources for your data. You can aggregate and do filters and so on, transformations of the data. Again, there's state being preserved, and then it's sent on to a sink. So the implications of this are important. We have the ability to make on-the-fly application code upgrades. So you have the ability to pause streams with Flink. You can make changes to your application code. You could even upgrade your Flink version. You can perform maintenance and migration. You can change the logic, to try something. You could even insert some A/B testing and then resume. Flink knows where it left off. It picks up from there and then processes things. And you can also, using what are called save points, you can mark a particular point in the event stream and say you want to go back to this event stream or go back to this point and redo the processing of that. So it's very resilient, it's fault tolerant, gives you this very convenient, for DevOps purposes, a real convenient capability to make changes on the fly. So how does Flink differ from some of the other stream processing technologies? There are two key ones. There are others out there, Samza and a bunch of others. But for the most part, Spark Streaming and Storm are the ones that have garnered the most attention. Typically, when you're dealing with stream processing, there are three concerns, and with existing solutions, you were typically required to choose only two. You could pick any two, but you couldn't pick all three because the challenge of dealing with streams was very, very difficult. So with Spark Streaming, you have high throughput and you have some fault tolerance capabilities, but you don't have necessarily the correct semantics, exactly once semantics. Storm was a popular stream processor as well. It could do well with low latency, so it dealt with data that was hot, did that very well. But Storm was very tricky to run under stress and to be able to provide fault tolerance and to give you exactly the kind of exactly once semantics that you need. And then of course you need the ability to implement your own logic. Spark can do a fairly decent job of that, but Flink does a great job of providing the appropriate abstractions for dealing with streams without you having to worry about the underlying fault tolerance and throughput and so on. Those are taken care of under the hood by Flink. So bottom line, Flink is unique in that it addresses all of the streaming challenges that we've previously identified, but in particular low latency, high throughput, and fault tolerance. What about performance? So here there was a Yahoo streaming test that was done to compare various technologies. The test was essentially provided a source of data or generation of data, manage that in some kind of transport, stream transport capability, and then feed that into a particular system. In our case, we're going to focus on Flink. Do a variety of things, standard things as part of the test, parsing, filtering, transforming, etc., roll-ups, group bys, etc., and caching that data, and then being able to serve queries on that data in real time. So that was the test. What was found was that although Spark Streaming garners a lot of the attention for stream processing, it actually doesn't scale particularly well. The latency suffers as you increase the number of transactions per second. Storm did pretty well. As we know, it focuses on low latency, and Flink did very well, very comparable to Storm. Okay. If we look at another measure, which was transactions per second, and move it to a scale of millions, you can see that this is all Flink here. Flink does quite well. There's 100 keys. It does 15 million transactions per second, and if you move it to a million keys, it's still, it hangs on there, still does well. And then if you're leveraging, this is again querying a separate system, if you take the downstream storage out of the equation and leverage the queryable state that you can get from Flink itself, and then look at 1 million keys, you can get back to 15 million transactions per second. So Flink itself is very high performance, and some of your throughput, of course, is going to be dictated by the downstream query engine that you use. In addition to that kind of architectural robustness and the focus on those stream processing challenges, Flink also comes with a bunch of new connectors that allow you to place it downstream of a variety of streaming transports, things like Amazon Kinesis streams, Apache Kafka, Elasticsearch, the Twitter Firehose, and even a database like Cassandra. So what's the validation that Flink actually works well? So you can see we have a variety of large companies, Alibaba, Capital One, Ericsson, and a bunch of others that are, some of them, the Auto Group, I believe, is the world's second largest e-commerce site. And so you've got, and then this is a large gaming platform. So you've got large scale platforms in production that are using Flink and succeeding with Flink. Okay, so as people know, Spark streaming is the one that everybody thinks of when they're thinking of implementing stream processing. So the question boils down to when would you use Flink, and when might you stick with Spark streaming? So some considerations. If the workload demands a truly real-time stream processing with low latency, high throughput, and fault tolerance, as we talked about, if you're not yet heavily invested in Spark streaming, a number of companies are. They have existing production systems with Spark streaming. Their staff has training and experience on Spark. But if you're not yet there, then that's a possibility. And if you want this convenience of being able to pause and replay, go back in time to an earlier point in the stream, and to be able to replay data and reprocess the streams after making system changes, if those conditions are relevant, then Flink might well be a good option for you. On the other hand, if you're primarily doing batch processing, Spark, given its maturity, that might be the best solution. As I said, if you're already invested in Spark streaming, if the micro batching paradigm that Spark streaming does, so just to back up 1 second, Spark doesn't do true stream processing. It processes the data in user-defined windows, typically like a 1-minute window, etc. And so it does things in micro batches. If that paradigm is acceptable for your particular workload, and that gives you the performance you're looking for, Spark might be the answer. If you need to code in Python or R, Spark is mature in supporting those. Flink has Python and R support, but it's still fairly new. And if you just want to wait and see how Flink matures before adopting it, then sticking with Spark might be the way to go. Okay, so the question now is, how do you deploy and run Flink in AWS? Well, for that, we're going to do an interesting demo here. It's a visual demo. This is showing, these are screenshots showing what the final results look like. And just so you're prepared to see what the results look like, what it's showing are maps with real-time information superimposed on the maps. This is Long Island here, and you're seeing here these are taxi cabs, New York City taxi cab data. So what we've done in this demo, and you'll see this, we're leveraging a data set that the New York City put out that includes over 1 billion taxi rides starting from the year 2009 all the way up to the current date. It includes both yellow cabs and green cabs, but over 1 billion records with timestamps, with GPS coordinates, with details about the how long the trip took, and all kinds of details. So it's a very interesting data set, and it can be rendered, given that it includes GPS information, allows us to have a geospatial interpretation. And then also in the third panel, we're showing the time that it takes for, or the average number of or the average duration of trips to LaGuardia and JFK airports. So you can see as time goes on, it changes. All right, so that's what we're going to build. Let's talk a little bit about what this demo architecture will include. We're going to have, of course, for stream processing, a replayable log. Okay? We're going to have a stream processor. Of course, that'll be Flink. And then we'll do some interesting visualization. Just to get concrete, what we're going to do is leverage Amazon Kinesis and Amazon EMR with Flink deployed on that. We're going to consume the data with Amazon Elasticsearch, and we'll talk about all these, what these services are in case people are not yet familiar. EC2 is our virtualized hosting, and so we'll SSH into that and run various commands, including pumping data into the stream, stream transport, and also leveraging that host to do some visualization. Okay. So let's talk about these components. Amazon Kinesis, it's Amazon's real-time streaming capability. It's very high throughput and elastic. It accomplishes that through sharding. So as the demand on Amazon Kinesis grows, you have the ability to either automatically or manually increase the number of shards to essentially give you parallel pipes, if you can think of it that way. And each of those pipes has an individual capacity, so you grow the capacity by adding more shards. It keeps a replayable log of events, so Kinesis will persist the data for the standard time is 24 hours, but you can increase that to 7 days. It's very easy to use. You'll see how trivial it is, and it integrates very well with a bunch of other AWS technologies. Amazon EMR, so this is what we'll run Flink on. Amazon EMR is a dynamically scalable Hadoop as a service, but actually more. It's a massively parallel compute as a service. With that, you can create transient clusters that come and go, or clusters that you keep running 24/7. EMR includes a whole bunch of applications, 17 of them to date, and we continue to add to those. Flink is now one of those. It's easy to use. You can very quickly, in less than a minute, specify what you want in a cluster and spin it up. It's fully managed, so it takes care of spinning up the underlying servers, connecting them, configuring them, installing the software, and making them usable, as well as managing the collection of clusters, or a collection of nodes as a high-level cluster abstraction. It's on demand, or the pricing is on demand by default, but you can leverage reserved pricing and also easily take advantage of spot instances or unused capacity that we allow customers to bid on. It includes a variety of persistence layers, HDFS, the common Hadoop one, S3, which gives you tremendous benefits, gives you a low-cost storage with a whole bunch of benefits like durability and life cycles, et cetera, et cetera. And if you need lots of local storage, you can increase the node disk space with elastic block storage. And importantly, it provides end-to-end security. So you have the means, should you choose it, to accomplish access controls over who can control the EMR clusters, firewalls, and VPCs, subnets, ingress, egress. You can control all that, but also importantly, encrypt from end to end in order to operate EMR. Amazon Elasticsearch service. So this provides and helps you run an Elasticsearch cluster. It reduces the work required to do that. Elasticsearch, of course, is an open source application that generates indexing of streaming documents and messages, etc. It includes the complete stack, the Elasticsearch, Logstash, and Kibana stack. It's, as I said, fully managed service, zero administration. You'll see how straightforward it is to manage. And highly available and reliable, and it scales quite well. All right, so let's jump into the demo. For that, I'm going to switch to my web browser. Okay, so if you remember, the key components we're going to deploy are Amazon Kinesis stream. That's up, and then downstream of that we'll have EMR with Flink, and then downstream of that we'll have Elasticsearch and Kibana. So what I'm going to do is show you how you would deploy each of those. It's very easy. So here we can just browse or type in Kinesis, and so here's Kinesis. So we switch to that. We're going to use Kinesis streams. There's Kinesis Firehose and Analytics, which you can also use. That's fine. I'll create a new stream here. So we need to give it a name. So we'll say Taxi Analytics, or we'll just call it Taxi Stream. All right. And so with Kinesis, you have upstream producers, some source generating data. As I mentioned, you have your capacity determined by shards, and then you pass on the data downstream to some consumer, which in our case will be EMR. So what we're going to do is just use the estimator here. The average record size, we'll say, is 1 KB. Let's go with 15,000 records per second. There's going to be one consumer application. That'll be our Flink application. So that generated a calculation of 15 shards, and we'll go ahead and use that value. It plugs them in below, and then we create the stream. And that's it. That is now spinning up the taxi stream. It'll take 30 to 60 seconds. In the meantime, we'll now move on to EMR. So let's go to, there we go, EMR. All right, so let's create a cluster. Now there's a simple view of EMR cluster creation and then an advanced one. We're going to switch to the advanced one because we want to be somewhat customized here. And so what we're going to do is we need Hadoop. We don't need Pig. We don't need Hue. We don't need Hive. We do need Flink. And that's we'll throw in Ganglia there as well. That's for monitoring and stuff. All right, and then we can click on Next. We'll throw it into a VPC with a subnet. Let's increase the core nodes to 3. So EMR organizes nodes into a master node, a bunch of core nodes, and a bunch of task nodes. Task is really just CPU and memory. They're doing mostly just processing of the data. Here we because of the persistence that Flink does, we're going to leverage the core, which does have data storage capacity, and we'll go with the C4 large. Okay, all right, and next we'll just keep the defaults there. We'll skip the bootstrap actions. That's for customizing it, and we need a key pair so we can get in to SSH. And if you want to customize the cluster's role, we provide defaults, but you can modify those as you wish. You can leverage a bunch of security settings that you've created, if you like, etc. But we're just going to keep things simple. Okay, that's it to launch an EMR cluster. It's starting up. You can see the applications that we've requested. Logging will go to S3. It's trying to provision the hardware, and you'll see that down here as well. So provisioning, and that's it. So EMR is ready to go. All right, now we're going to move on to Elasticsearch. There we go, Elasticsearch. Okay, we're going to create one called Taxi. We'll call it Analytics, I guess. Stay with that version. Okay. And the instance count, make that 3. And stay with that instance type. And that's it. Oh, and then we apply an access policy. This is related to security. We're going to reuse one that hang on, did I pick the copy? Oh, here we go. Let's go with that one. So IAM access policies underlie everything within IaaS, and it's a very precise, very fine-grained way to control who can access what and what functions on different services. So this is giving us the ability to work with Elasticsearch, allowing any component to work with that. So we're going to use that, and then confirm and create. Okay, there we go. All right, so we've got our infrastructure spinning up, and those things should be ready pretty quickly here. Now, rather than waiting for those to come up, EMR will typically take about 10 minutes or so to spin up all the different nodes and copy software, configure, etc. But rather than waiting for the infrastructure to spin up, I've gone ahead this morning and spun up infrastructure for the demo. So I'm going to go ahead and use that. So let's go to, okay. So we're gonna SSH into the node, or the master node on the cluster that I spun up this morning. So let me switch to our terminal. Okay, I think you're seeing my terminal now. All right, and so we've got some things we're going to just cut and paste in order to SSH into. Okay. All right, so I need to change my key file. Okay, so this is going to do two things. It's going to SSH into the EMR cluster, but it's also going to set up a SSH tunnel so that I can access the UI, the web UI, running on the master node. Okay, so we're in, and so now what I'm going to do is start a yarn session. So, all right, so this is just it's running the yarn session that we're going to leverage for Flink. There's no errors here, so it's all just info. It's reporting what's going on. This eventually stops. Okay, and then next we're going to download our application that we're going to run on on Flink. Okay, so this pulls down a jar for us that has our custom logic for processing the taxi data. Okay, so we've got that. And then finally, I'm going to run Flink with our jar custom logic. And what you'll see is it starts to produce some activity. Now keep in mind, we've got no data flowing into the system yet, so it's really just spinning up, deploying, not spinning up, but deploying the application and running it across our pre-existing cluster. And now what we're going to do is we're going to switch to the, well, we're going to go to the EMR cluster. Let me switch to the back to the web console. Okay. So stop sharing the. Okay. So you should now see we're back on the web console. Now what we're going to do is go to that EMR cluster that's running, our pre-baked one, I call it. Okay. And so as a result of the tunnel and are using something called Foxy Proxy. It's a web plugin that allows us to send network traffic, web traffic in particular, to, based on ports to a particular application. Here we're now connected to the EMR cluster through the web console, and we have a bunch of applications running on the EMR cluster. So we're going to click that and shrink that window a bit, and get rid of this. And then so here we're just looking at what applications are running on the cluster, and this one is the Flink that we launched. Okay, and so you can see now there's, hang on. Okay, so here's the graph of logic that Flink is operating on. So it's receiving data and then sending it to the three panels, or sending it downstream to what will eventually be the three panels that that we're going to look at. And so anyways, we're in Flink now, and what we're going to, since it's empty, it's not receiving any records here. Let me shrink this a little bit more. Oops. Yeah, so we're not receiving any records yet, and that's because nothing is going into the Kinesis stream that we set up. So let's now go to let's go into the host that we set up, this bastion host that you saw in the diagram. And so let me grab the command for that. And I need to switch to my terminal. And I'm going to open up a new session. Where did it go? So we'll pop up a clean window here, and what we're going to do is paste this in, and this is going to allow us to SSH into into the host that's also going to run Kibana. But we're going to use this to run a producer that's going to feed data into the Kinesis stream. Okay. All right, so we're SSH'd into that EC2 host, and now we're gonna grab a file, pull down a file, and this is a jar this is a jar for a producer that we're going to execute this. So you can see it's called taxi stream producer. So this is what's going to generate records that go into the Kinesis stream and here we go, producer command. So cut and paste this command. So we're going to run that producer jar so that it pumps data. It generates, and what it's doing is pulling data that lives elsewhere, lives on S3 it turns out, the New York City historical taxi data set, but it's pulling it out record by record using event time and pumping those into Kinesis. So let's run that. And pretty soon you'll start to see that it says it's generating records. And now if we switch, we just leave that running. If we switch back to the the Flink, we switch back to the Flink web console. I grabbed the wrong window here. Okay, so now we're back into the web console for Flink. It's the Flink application, and now you'll see we've got data coming through, all right, and so it's running, and we've got records coming through. Actually, let's take a look at this. Right, so upstream of everything, we've got these records coming through in real time. And then for the last step, we move to the Kibana display. And so for that, we're going to visualize the data. We're going to connect to the Kibana host. So hopefully you can see this, local host. This is also using an SSH tunnel. Okay, so this is the Kibana running on the Bastion host that we set up, and what we're going to do is index on. We're going to index on taxi dashboard. Okay, and create. All right, and so that's just showing us what we're pulling. Now to get a visualization, we need to go to settings, objects, and then we're going to import a JSON file that corresponds to the visualization that we want. Give me a second while I find that. Okay, I got it. All right, so there's a taxi dashboard that's defined, and we're going to look at that. That's our visualization. Okay, and as you saw on the earlier slide, we have a geographical summary of pickups, and so we can zero in. And as we zero in, it gives a finer grained breakout of the regions within New York. Okay, and so just one more here. Okay, So this is, you can see the legend at the bottom. This is the number of pickups. So this is data that's been streaming through Kinesis, through Flink, passed on to Elasticsearch, and then we have the visualizations here through Kibana. And very quickly, just zeroing in on this. This is the idle time, idle duration for cabs. And as the data continues to stream through, this gets updated, and you can see things. And then we have the graph for the processing, for the time to the cab, for cab trips to the airports. Okay, so one last thing just to show you, we set this up with a particular capacity, and what we are now going to do is switch back to the web console. All right, and right, so we go back to the console just to show you how we have elasticity for what's needed. We're going to go back to our Kinesis stream, and we're going to enlarge the stream dynamically. So here we have this one here that was set up before, and what we're going to do is drill down into that. Here we have 15 shards, if you remember. We're going to now increase that to 20. Okay, we just changed the open shards to 20, save that. So it's now in the process of dynamically expanding the number of shards on Kinesis. Let's do something similar on EMR, our EMR cluster. This one here. Okay, so let's go down to the hardware. And if you remember, we had three core nodes, so let's change this now to 6. Okay, and what you'll see is it's still at 3, but now it's saying that 6 have been requested. And so now you'll start to see over time, within about 10 minutes, the number of nodes on EMR would be enlarged. And similarly on Elastic Cache, you could expand the capacity there. Let's switch back to the slides, just to wrap up. Right, so if we can summarize, so for predominantly stream processing workloads where you also happen to do some batch processing, Apache Flink has a lot to offer. It simultaneously addresses those 3 major concerns of high throughput, low latency, and fault tolerance. It can do both stream processing and batch processing with a single technology rather than a mix. It's got powerful windowing functions, so it allows you to process and analyze the streams in a variety of ways. It has convenient capabilities to pause, restart, and change Flink applications on the go. Flink's still new, but there is adoption, some serious production adoption. And you know, so maybe it's not quite as far along on the adoption curve as Spark Streaming, but it's coming. And as you've seen, AWS makes it easy to set up and run a streaming workload with Amazon Kinesis and Apache, Spark Streaming, or run Kinesis and either Spark or Flink. Okay, so I think we're ready for questions.
And thank you, Keith, for the great presentation. I want to thank Suman, Bruno, and Tony for engaging the audience throughout our session with the answers to our Q&A questions that have come through. We do have our poll questions open. You'll see 3 at the bottom of the screen, 1 at the top, so we do appreciate your feedback. Definitely thank you for doing that. We will make sure that we look at all our Q&A questions. Again, thanks for everything, and let's start our Q&A.
Yeah, I'll take the first question here. Are there any plans to getting Apache NiFi in EMR? AWS in general is very customer driven, and our product roadmap typically has 90% of the items that come from customers. EMR is no exception, and we will listen to what customers need and try to understand why it's important for them, and then we'll integrate that into what shows up on EMR. So reach out to us if you need NiFi, and we can drill down into some of those details. Second question, hi, will there be a similar demo in a later part of the session for Spark deployment on EMR? There are lots and lots of video recordings of previous webinars that go into Spark on EMR, and there's tons of documentation for Spark on EMR, so I would recommend you take a look at that. Also, third question or comment, but Flink's stable version is 1.2, the one in EMR is one version older, where it doesn't have checkpointing, etc. So EMR has a pretty high cadence. We are one of the most up-to-date and current Hadoop distributions available. We're typically 4 weeks or so behind the open source software as it becomes available. So check back in about a month, and you'll see upgrades to the various versions. Those are the three questions I have. If that's all, then I think we're probably done.
All right. Well, thank you, Keith. We do appreciate all your time and effort to put towards this great presentation. And again, I wanted to thank Suman, Bruno, and Tony again for all the great answers to the questions today. So if anybody has any comments on our previous or upcoming webinars, or suggestions on topics that you wish AWS to cover in future webinars, please feel free to email us at aws-webcasts@amazon.com. Your feedback will help us improve our webinar programming. Thank you to the audience for taking the time to be with us today. Enjoy the rest of your day, and thanks again for joining.